Bismillahirrahmanirrahim. Assalamu alaikum ji. Welcome back to machine learning. We were talking about a naive Bayes classifier. In the previous video, we made an attempt to design, to define, and formulate a naive Bayes classifier. So here we will focus on one application of naive Bayes classifier, that is text classification. Text classification is used in a variety of applications of science, engineering, and beyond. Applications of text classification include sentiment analysis, or we can use it for spam detection, or we can use it for language identification, just to name a few. These applications may also include, for example, topic labeling or intent detection from the text. Okay, so what is the classification problem we have? So in text classification, we have an input, which is a document. It could be a sentence, it could be a statement, a document, and a fixed set of classes. For example, if it is for spam detection, it can be spam or non-spam. We have two classes. And output for a classification problem is that we want to predict class for the given document. If you don't want to use machine learning, we can have a classification method that we call hand-coded rules, that we can define some rules based on combination of words or other features to carry out prediction for a class of the given document. For example, if you want to detect a spam email, we can blacklist some of the email addresses. We can blacklist we can classify as email as spam if you find dollars word in the email, or you find you have been selected phrase in the email. But what's an issue with hand-coded rules? So for these hand-coded rules, you can get a very high accuracy if these rules are defined by expert, right? But building and maintaining these rules is expensive. You need domain experts, you need area experts to first refine these rules, and then you must be maintaining these rules, and you must be updating these rules so that these rules are up to date. Because the people who are sending you spam emails, they might be using machine learning if you're not using machine learning. So we can have hand-coded rules, but building and maintaining these rules is expensive, and it may not be robust. In machine learning, or we call in supervised learning, we have the same input, a document, and a fixed set of classes. And we also have our training data. We have n number of documents, and for these n documents, we have label assigned. We have a class label assigned to these documents. And we want to build a classifier. We want to learn a classifier that can help us in carrying out prediction for a given document. So for this classification problem, in the context of supervised learning, we can use any classifier. We can also use k-nearest neighbor, or we can use naive Bayes. Although we have not covered yet, we can also use logistic regression, or we can use neural network, or we can use SVM. We will cover all of these very shortly. But here we will build a simple naive Bayes for text classification problem. Naive Bayes relies on a very simple representation of a document, what we call bag of words. So what is bag of words? The concept is very simple. The idea is count the number of times each word appears in a document. And it's based on assumption that position of the words does not matter in the text document. Whether the word is appearing in the middle of the document or at the start of the document, for bag of words, the representation is same. So in bag of words is a representation of text that describes the occurrence of words within a document. For example, if you have this text, And if you pass this text through a bag of words, we get this representation. So it in the Word document is appearing 6 times, I is appearing 5 times, and so on and so forth. So we get information about the number of times each word appears in a document. This is a bag of words. Okay. Before we build Naïve-based classifier, let's also talk about some of the terminologies and some pre-processing we apply on text documents. Okay, corpus is a collection of documents, data, usually we use for a collection of documents for text classification problem. We also use the concept of vocabulary, and we denote it by capital V. And vocabulary is the union of all the word types in all classes, not just the one class. Right? So it's a collection of the words which you can find in all of the training corpus we have. Right? Okay. Okay. For pre-processing of documents, it includes first of all, you want to clean the corpus. For example, you can have three different types of hello in your document. Hello, 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 and what you want, you should treat these three hello as same. And to make them same, the common cleaning includes you can remove numbers from the document, you remove punctuations, and you also remove excessive white spaces. And cleaning also includes representation of all the words in lowercase, and this will help you in resolving the first two hello words. Let's also talk about the concept of stop words. Stop words are the words that are occurring very frequently in your document. For example, you can have a or the. So the idea is we sort the whole vocabulary by frequency during training stage, and we call the top 5 or 20 or 50 words the stop word list. And once we had defined the stop word list, we remove all the stop words from the training and test sets as if they were never there. So we just remove the stop words from the documents or from the back. Right? So this is the concept of stop words. But in Naïve base, usually we do not remove stop words and we use all the words. So after pre-processing, we create a mega document for each class by concatenating all the documents of the class. So for each class, we simply concatenate, we just group all the documents we have. Because we will pass this mega document through bag of words. We will process this mega document using bag of words. And since bag of words returns you a frequency table for each class, this concatenation or creating a mega document would help you that you will process all the documents for each class using bag of words in one go. Okay. Okay, let's talk about one example, and we will build Naïve-based classifier for spam versus non-spam email detection. Assume we have this information. So we have 4 documents that have been labeled as spam, and we have 2 documents with non-spam label. And these 2 are our test, and we want to assign label to these 2. If I ask you vocabulary for this training data set, so vocabulary would contain these words. You have sent appearing multiple times, but in a set you only have one representation. As your password review account. These are the words which are in the training, which make every document in your training set. If you observe here, there are a couple of issues which we would like to resolve as we progress. The first issue is that in your test documents you have this, you have a review, you have us, you have now, you have review, and you have account. Right? If you see, this now is not in the training data, or we can say this is an unknown word, or we call it out of vocabulary word, right? Just to resolve this issue, we have a very simple solution. We remove out of vocabulary word, we remove unknown word from the test document. It simply means when we carry out classification for review us now, we'll only use review and us. We will not use now because now is unknown to us. Okay, so there's another issue, and the issue is this word account, which is appearing in the second text document. This is only available in one class. So account is only available in spam class, but not in the non-spam class. But we can also solve this issue. And the solution is we use add one smoothing to resolve this. And we will see this very shortly. Right? Let's build a Naïve based classifier for this example. So first, we look at the formulation of Naïve based classifier. So this is what we had for Naïve based classifier. That's how we defined that we maximize over different classes. So here we only have two classes, spam versus non-spam. So this y is 0 or 1, spam, non-spam. And we want, so maximizing this posterior would be equivalent to maximizing likelihood times prior, and where we have used the assumption that all the features are mutually independent, and therefore we have written the joint distribution as a product of individual distributions. X here represents the test document for which we want to carry out prediction, and we are using for text classification here we'll be using each feature represents a word in the document. So what is D here? So D represents the number of features. So D here represents the number of words in the test document. If your test document has 3 words, so you will be computing 3 probabilities here. If your test document contains 100 words, we will be required to compute 100 probabilities here. And for example, for our test data review us now, D is equal to 3, and for X is equal to review account, D is equal to 2. So this is, we have simply modified the formulation for Naïve based classifier for text classification. Okay, let's use bag of words approach and create a bag of words for this training data we have. If you pass only training data through bag of words, so we get this frequency table. So how do you interpret this? The word sent is appearing 3 times in test documents, in training documents that has been labeled as spam. The word send is appearing once in non-spam documents, and so on and so forth. Right? Okay, let's carry out prediction for X equal to review us now. Right? So what do we want? We want to compute probability of spam given this X and probability of non-spam given this X. And we will assign a label for which we get the higher probability. Right? Let's compute these probabilities. So for execute reviewers now, obviously now is unknown word, it's out of vocabulary, it's OOV, so we can remove, so you can simply remove now. So we only have review and us. And we compute these two probabilities. First compute probability of X given spam times probability of spam. Probability of X given spam would be given by probability of review given spam times probability of us given spam. Right? So I can write this as this because we have D is equal to 2. We have product of two probabilities. So what about probability of review given spam? So its spam is given. When you talk about review, we can estimate review is appearing only 1 times out of 13. So in spam, total word count is 13. Probability of review given spam would be simply the number of times the review is appearing divided by total number of word counts in spam. So that will be 1 over 13. Okay. Can you compute probability of us given spam? Similarly, we have 3 by 13. And finally, what about probability of spam? So in our training data, we have 4 spam emails and 2 non-spam emails. So in total, we have 6 documents or 6 emails. So 4 out of 6 is that you get a spam email, you get a spam document, right? If you use these numbers, we can compute probability of X given spam times probability of spam, that will be 0.02. Let's also compute probability of review given non-spam, that will be 2 by 6. Probability of us given non-spam would be 1 divided by total number of word counts non-spam. Probability of non-spam would be 1 minus probability of spam or number of spam emails, number of spam non-spam documents divided by total documents, that would be 2 by 6. Okay. If you multiply these 3 probabilities, you get 0.0185. Okay. Or you can say that, which one is greater? 0.0185, right? So we can say document is likely a non-spam. Okay, let's also classify the other test document we have. We want to carry out prediction for a review account. We carry out the same approach, but we have an issue here. Recall, if you see the word account, non-spam count is 0 here. And consequently, we have an issue with this, that probability of account given non-spam would be 0. When this probability is 0, when we compute probabilities, we multiply different probabilities. And because of this 0, the product would be 0. To resolve this, to handle this, we discussed one solution in the previous module, and that was Laplace smoothing. You add small number to the count. Okay, we call it add one smoothing. Okay, what is the idea? The idea is we simply add 1 to each count in each class. Okay, if we use this, so what about probability of spam? That will be simply 4 by 6. Probability non-spam, that will stay the same, 2 by 6. If I ask you, what is the probability of review given spam? If we don't use add one smoothing, that will be simply 1 over 13. right? But if we use add one smoothing, this will be, instead of 1 over 13, we add 1 in the numerator and we are adding 6 in the denominator. Okay, why? Because we have added 1 in each for in account for each word, right? If you add 1 in each word, so this 13 would be, become 13 would be, you add 6, 13 would be 19, right? So we add 1 in the numerator and we add 1 times the number of words you have in the vocabulary, right? Or this would be simply 1 times the cardinality of the vocabulary. In this case, the cardinality of vocabulary is 6. Okay, so this is V, the size of set V. Right? So if you compute it, that is equal to 2 over 19. Similarly, probability of account given spam would be 2 over 19, right? So we have added numerator factor times the size of the vocabulary in the denominator. Similarly, we can compute probability of review given non-spam. That would be, so 2 plus 1, you add 1 in each entry. So obviously this is going to add bias to your estimate, but this can help us in handling this issue, that for some item in the vocabulary we do not have a count in one of the classes. So we have smoothed the data, right? We had some zeros, and with some smoothing, we have smoothed the data. Probability of account given non-spam would be simply 1 over 12. Right? If we don't use add one smoothing, this would be 0. This won't be 1 over 12. And if we use these numbers, we get probability of x given spam times probability of spam would be 0.00738. And probability of x given non-spam would be 0.00694. And if you compare these two probabilities, you can say that document is likely a spam, right? So so that's all for text classification, and we have developed a Naïve based classifier. We have demonstrated the use of Naïve based classifier for text classification. You also I also gave you an idea about some of the processing we apply for text classification, right? We stop here. In the next video, we will focus on a very brief introduction to Bayesian network. Thank you, Ji. Allah Hafiz.